And then we can start. I don't think this will take the whole class. I don't think you'd want me to talk the whole class. The blog is there if you want to read it, but I'm just going to talk. I did. I should have done probably the show tracker, and I may still do that. I might actually build that application out. But instead, I did one of my old favorite examples, which is a card game.
Have you actually created?
This one, all this card game does that I gave you, all it'll do is deal out a hand. That's all it does. But it wouldn't be very hard to, I mean, I could probably easily turn this into, I called it a blackjack game. It'd be pretty easy just to add the rules for blackjack. Blackjack is a real easy game. I mean, the rules are pretty clear. So I could probably turn this into a game fairly quickly. And I have in the past. I didn't do it here because I didn't want to focus on the presentation classes, but I've built out forms, and you can find on the internet all sorts of card deck pictures, so you can make pictures of the cards and things. I mean, it's not hard. So, I mean, it's not easy either. You have to know kind of what you're doing, but mainly it's the objects. So when you're going through this, I'm just kind of doing the process again. So the idea was to create and one of the things that I was thinking with this card game thing is that it would play multiple different card games. Yeah.
I don't think the link to that blog is
Should work. So yeah, refresh. Go down to. Why does this not happen?
What's it under?
Did I not share it?
I don't think so.
I can
Because it's
fix
not
that. I can fix that. It's not published. It is published now. So if you refresh, is it there?
Yeah, it's there. Class relationships.
Yeah.
If you scroll to class subject, like the grade.
So are we got it and ready to go then? So the first thing I did, and this is what I would advise you guys to, is just to think about what kinds of objects naturally belong to the thing. So this is the domain part. As I said, a lot of you, because of my first example, I think went for the users, but the users are not necessarily the objects. When you think about a card game, I have like the dealer, the card, the deck, the player, the hand, and the turn. Those are what I came up with right away. One of the things you can do is kind of talk about it, just tell a story about it. That's what they do in Agile, they tell stories about it. And then when you look at that, if you look at all the nouns, those are probably a first guide to your objects. Does that make sense? So, card game, again, I wanted an example that was fairly simple. This list is like a preliminary list. It doesn't necessarily mean that that's going to be your final object list. So, does that make sense? Anytime you have questions, stop me, because So I made an initial card class. So once I had these objects, I started to do this. This one just has a string for the suit, and then I did a card number, and there's 13 cards in a suit. So I labeled them 1 to 13. It's easier to do that than to say if it's an ace or a king or etc. The number is not necessarily their value, because aren't all the face cards 10 in blackjack? But it would vary with games anyway. And you could assign pictures to this and make it a little bit more. So here, this is just a string, and this is a preliminary thing. So the card is just an object that's going to store the suit and what number it is, and from the number you can figure out what card it is. Does that make sense? If it doesn't, stop me. I don't have any methods in that, right? It's just that. And again, one of the things that I'm going to do is I'm going to do a preliminary design, and then I'm going to refine that design with a little bit of refactoring. So my deck is just a list of cards. All right, so one of the things I put in here is a method to populate the deck. I mean, basic, and it's private, because I just figured that when you call a deck, it'll automatically put 52 cards in there, right? So you can just do that. I did put a method in to shovel it, and then I put in a method to get the deck. There is some question as to whether these belong in the deck. Does that make sense? Because if they're kind of manipulating the deck, they maybe should be another class. I'm still debating that. Does that make sense so far? Now, when we talk about relations, we'll talk about composition. When you have a list like this of an object inside of another object, that's a good sign that it's aggregation or composition, right? Because it's containing one. This object contains another object, and actually a list of the other objects. Mind your way for this. Okay. So when you play anything, you usually have a hand. The hand belongs to a player. So again, a hand is just a list of cards. It's not as extensive as a deck. It's just some of the cards, right? I had a method to add a card and remove a card from the, from the hand. So you can play a card, you can draw a card, right? And then player, I gave them a name. They possess a hand. Points I'm not sure of. And then I did a method that says that they can play. I'm not sure of that either, but that's first take kind of things. Does that make sense so far? Would you guys, what do you think? Could you come through and figure out methods, objects like this? I mean, it's fairly natural. What is it that belongs to the topic you're working with, right? And this is a simple game. These I might need to make bigger. I just want it so you can see them. So this is, again, as a first take. I said it would be playing several games. And I did it this way to kind of prove a point or to show a point later. I did like several different games. Blackjack, Crazy Eights, and War. You could have other games. The idea is you could just keep adding modules for games. There's one of the things to note is that each of these has basically the same 3 methods, right? So when we revise things, anytime you find yourself repeating stuff, there's a problem. You shouldn't have to do that. They also have essentially the same fields. And I would suspect when I actually get into playing these, that I'd have to make these much more complex. I'm not entirely sure what all we're doing there. Right now, the turn is where all the game logic would be, and I suspect that's not the case. But just, just for the point of creating these classes. Okay. Can I get out of here? Go back. All right. So when I do the relationships, and this is a first take, I did card as a composition to the deck. Theoretically, if you throw away the deck, the cards are gone. You could debate that, but that's how I'm treating it. So each of these has a deck. So the deck belongs. If you get rid of the game, then that deck is gone. These could be aggregation too. Again, that's debatable what they are. A player has a hand. The hand belongs to the player. If the player quits, the hand goes away. So this one I'm pretty sure of is composition. And these are just a tangled web of association. And I tried to get the line straight. They didn't do it. So that's my first take of relations. Does that make sense? You guys are really quiet, so I'm not sure if it's making total clear sense or just totally incomprehensible. All right. So this is, you guys know the term refactoring. So you can do it in code, and you can also do it a little bit here. Part of it is part of it is like encapsulating a field in its sets and gets, right? So part of refactoring is creating the sets and gets. Another part of it is when you find that you are repeating the same code in different methods, you can extract the code and just create one method, right, rather than several methods. Again, anytime you find yourself repeating yourself within a class or between classes, you should extract that and find a way to put it in just one place. So I went through a lot of changes in this other diagram. One of the things that I did is I did an enumeration of suits. You guys know what that enums are? Anyone not? It's fine if you don't. Yeah. So an enum, and I'll show you the code for it in a moment, is basically just a list of things where you're giving them a name. It's basically a key name value, key value pair. And you're storing it up there. So this would contain the names, hearts, clubs, spades, etc. The advantage of doing something like this is that the names are in one place. There's no chance of typing it wrong later because you can just refer to this. It makes it for consistency, and it makes it an easy reference for that. It's actually a good idea a lot of times. There are lots of these that exist in programming languages. Typically, when you do a programming language and you have colors, the colors are part of a really large enum because underneath it will have the red, green, blue values. But they'll give them names so you don't have to type in the red, green, blue values, etc. So I did that for that. So down here, instead of a string now, well, it is string, but it's string suits and then suit name. So it gets the suit name from me. This is suits, so suits.suit name. Other than that, it's the same. For the game, as I made the biggest changes, and part of this is just to show you things. One of them is I made the game a new class called game that is abstract. By being abstract, who knows what abstract means? Yeah.
There's no object that can be made out of it.
Right, you can't use it directly. You can only use its children. I also created an interface. They all had the same methods in them. So there's a couple of ways you could do this. You could have each subclass inherit the interface or implement the interface. But if you have the abstract class and do it, then all of the children have to by default do it. So that's what I did is I made the abstract class implement the interface. And the neat thing about an abstract class in Java anyway is you don't have to put any code in here for this, but the children do. Right, it inherits that. I also put the two fields up here because they were the same. So I don't have any real content in my games, but the way that these would be implemented would be different in each one. Does that make sense? Because each game would have different rules and they would probably have more methods too. I didn't try to fully realize any of this stuff because it would take weeks and I only had a couple hours. Does that make sense? So the main thing I want to get, there was that first diagram. And it was okay. So let's go back to the first diagram. But there was a lot of repetition, and the relationships were a little bit strange. So these are all basically copies of each other, except that the inner code would be different. The list of cards here, the string probably, but not the list, the card. I forgot to take out, I had the name and the picture here. I should have removed those because I decided not to use those. But the suit as a string could give some inconsistency in that. So basically the second example is a refinement of the first. And I'm sure if you were really good, you could probably refine this more. But one of the basic rules is that whenever there's repetition, you always want to move things out and abstract it as much as possible. An interface where it abstracts the methods. The abstract class to capture the common fields. The enumeration to capture the names. The more you want to put things in one place only and to abstract it as much as you can. learning to do that takes time and experience. It's not an instinct. But the more you can do this, the more you can abstract things out, the more you can separate things, the more flexible your programming will be. Okay.
I have a question.
Sure.
Why is the between the hand and the game? Why did you choose segregation?
I decided that a game, there could be several, that a hand, it could certainly still be,
What's the difference in code between aggregation and composition?
none.
So this is just pure.
It's a concept as to whether the hand would exist separate from the game. I assume that it wouldn't exist separate from the player, but here, partially because I just wanted a piece of aggregation, I think. But in terms of the actual code, there's not much difference at all. In fact, a lot of people have argued that this is really just association by another name. Yeah, so. And the composition is just conceptually, is the object totally contained or not, right? And that's the only difference, but it actually doesn't change the code. So the relationships, it can tell you something useful when because we're not going to that level of sophistication, but when you're dealing some of the final things, you have to know what persists when something else is removed, right? So one of the things that you can typically work on it at some point in a application is what are the states of the objects. And so if you remove a deck, are there any cards left over, right? And that's a conceptual thing, but it can matter in terms of cleanup, right? When you're cleaning up your game and when you're trying to figure out what's going on or restarting the game. You know, if the card has a separate existence from the deck, you might need to make sure all the cards are removed as well as the deck. And, so it has some practical use in terms of ending the game, restarting the game, or cleaning up areas as you go on. Okay. Does that help at all? I'm going to show you the code, which may or may not help. All right, so I'm going to leave that up. Oh, I don't want that. I want this. So these are all on GitHub, right? And the link to GitHub is in the blog. I should probably put it in Canvas as well. What I did is I started a new project because I only uploaded I didn't upload a project, I just uploaded the classes. So I started a new object. I used the same package name that I always use, and I just imported the classes. So I'm going to start with the card, and we could go back and think. So notice it has, well, actually, maybe I should start with the enumeration. So let's look at the suits because the card does that. This is how simple an enumeration is. Public enum suits, hearts, diamonds, clubs, spades. Again, you could have more. Now, for what it's worth, this is like an array. There's also an integer value that goes with each of these. And you can access either the integer value or the word. I don't actually teach enums a lot in my programming classes. I probably should. But it's just public enum suits. So card, when I do the card, notice it's suits, so it's the enum, and then suit is just the variable name as well. And I'll show you, well, actually I could show you in the program. Well, actually it's not in the program, it's in the deck. We'll look at it later. Where it's actually used, where we actually give a value to those things. I have two constructors. I have a blank empty constructor, and I have one where you pass in the suit and the card number. And then the rest is just sets and gets for the two fields. Okay. looks more complicated than it is. This just gives you two different options for how to initialize the card. Okay. Does that make sense? So that's card. Let's look at deck. So the deck has an array list of cards, right? That's essentially what a deck is. It's just a list of cards. Now, there's some things I did in here that, as I said, I'm not entirely sure should go in here. But I did a constructor that initializes the array list and calls this populate deck method. And in this, what I have is an embedded loop, which is not always a good idea, where it takes for each of the values in the suite, you know, the enumeration. It goes through and it adds 13 cards for each suit, and then it just gives it the value of I. So 1 through 13. 1 would be ace, and 13, I guess, would be the king. Does that make sense?
You need to make it random.
What?
You need to make a random.
Well, so
Shuffle.
I do have a shuffle.
Yeah, man. Shuffle it. And you like distribute the color.
Yeah, this is the shuffle.
All of you saw.
Why is it not a good idea to have a
Well, so
nested loop?
because these are kind of manipulating the deck inside of the deck. You know, I
Okay.
still kind of see it as a deck, but the deck is an object. We're kind of manipulating the deck, including even just returning the deck, and this is a deck, right? So it gives you a copy. I don't know. It's just sort of self-referential a little bit. It's a debate. I mean, you don't want to have a customer have a method add customer, right? Because the customer is the object being added, not something that should add itself. But I think these are kind of fit in the deck still. That kind of makes sense. So this populates it, so it's not just empty. It actually has 52 cards. Now there are card games that don't take all 52 cards, so you may not want it that blatantly. And there are card games that use more than one deck. So I'm not trying to get all that fancy about all of these card games, but you might want to change that a little bit. This is a neat thing in Java. You can just do a collections, which is a built-in object, dot shuffle, and pass it the deck, and it will randomize the deck. That's so much easier than trying to write your own randomize method, which you can do, but why do when you can do that? And I've tested it. It actually does randomize it decently. So there's a method to populate the deck, a method to shuffle it, and then just to get a copy of the deck, return the deck. Does that make sense? If you're not a Java programmer, I know this probably doesn't make great sense, but
Pretty much looks like C#.
Java and C# they're just twins. What Microsoft did with C# is they looked at Java and they cleaned it up a little. That's all they did. I'm really surprised there weren't more lawsuits. They also both look like C++, which may be why there wasn't more lawsuits, because they both look like C++. So if you ever want to learn C++, if you know Java or C#, you're halfway there. The only thing you really need to pick up are pointers. And pointers happen, this is not relevant here, but pointers happen all the time in this. It's just that it's hidden from there. Pointers are basically variables that point to a particular address in memory. So, all right, so that's deck. Let's look at game, I guess. First, let's do the interface. So the interface has a deal, and what the deal gives back is a card. It has a turn, which takes in a player. So process a player for a turn. I didn't build these out. So if I were to build out those methods, I would probably find that I need to change the idea a bit. And then the turn result, I just figured this was where you evaluate the game to see what happened after the turn happened. That being said, these are, as you work through this, and this is one other thing I would say about class diagrams, as you actually get into the code and try to adapt the diagrams, or adapt the diagrams to code, you may find that the code forces you to go back and change the diagram. Does that make sense? It's not a final process. As you work through the code, you may find that the diagram needs to be adjusted, and that's perfectly fine. But you should adjust it. You should use it for documentation purposes. You should actually change the diagrams to reflect the code that you actually write. And these are real vague, and I didn't fill them. I didn't do anything with them. So they could easily change quite a bit. But that's the interface. The abstract class game, notice it implements the iGame, so it implements the interface. I did a protected deck so I could access the deck. I did a private game description, and I did sets and gets for that. I didn't have to do the interface methods because it's an abstract class. The only other thing I did is I did do a public string to string, because a chintzy way to figure out which game you're playing is that each class will say what its name is. So you could look at the toString and say, oh, we're playing Blackjack. Or we could look at, you could say you're playing Crazy Eights or whatever game you're playing. I'm sure there's a much more. Part of it was I couldn't remember. I know how to do it in C#, but I didn't remember how to do it in Java to get the type of the class. I thought it was just get type, but I was having no luck with that. It might be type of with a parentheses. I saw that, but I played with it very briefly, so it might have worked if I played with it longer. So as I said, this is kind of chintzy. I just get the name from the toString property. Does that kind of make sense? So that's that. Let's look at the Blackjack. I only implemented one of those ideas. So this extends game. So one of the things that it required, see the overrides down here, is it required that those methods be here. I still didn't do anything with turn and turn result. I just left them empty. In the constructor, which is up here, I did initialize everything, right? Because one of the things that get you in trouble is if you don't initialize your array lists, then they won't work. You'll get null exception errors all over the place. I did do deal, and I did toString. That's the only thing that I did for those. So you have the array list card, my deck. My deck is equal to the get deck from the so we create a deck and then we get the deck. I shuffle it first. Again, you might want to do that manually somewhere as opposed to just do it in the constructor. But anyway. This is a lot, considering that in the end, this is all I'm going to get. So let's look at, I think hand would be the object, next one. And then I think we're about done with this. So in a hand, a hand consists of an array list of cards also. And I've got basically add a card and remove a card. And then I've got to say, if you wanted to show your hand, you can just show your whole hand. That's basically all that's in here. Does that make sense? The thing is to compare this to the diagram. So, and in the blog. So let's go at the bottom of this. There's a part 2, and part 2 shows the classes, and then it shows the code. Okay. And then it shows the classes, and it shows the code, and it comments on it as you go through. So the blog might give you a better description overall of what's going on. So the very last thing I have is the program class, which is just the main where I run it. And again, there would be an interface for this. There'd be forms, there'd be menus, there'd be all sorts of things. So there'd be a whole layer of classes that have to do with just visualizing the game, getting started, recording the use of players and things like that. There might be a data layer. The only thing I can think that you would want it for is if you want to preserve wins and losses, and if you maybe to pull up the card images. Right. So what I do is I declare Blackjack as a new game, and I make it like, actually there was one other thing I wanted to show you. The player, when I have a player, I pass in a game, right? So this is in the constructor, so when I make a new player, I have to tell it what game they're playing. And we initialize the hand. And I said if G to string equals Blackjack, this G new equals new Blackjack. And there would be, I'd have to do a list of the different games that were involved there. Notice that this is game, and I pass in Blackjack. That was actually an important point, and I don't want to bypass it. One of the neat things about object-oriented programming is that any child can substitute for a parent. So I can put game up here, and I can put any child or game that will pass in and not cause a problem. The only caveat to that is that you have to basically you have to refocus it into the proper type. You have to cast it to the proper type. Because if you leave it as game, you'll only have, well, actually you can't because it's an abstract class. You can't initialize it as game. You can only initialize it as its child. But you can use game here and pass it through. Pass through Blackjack, pass through whatever game it is. Pass through War. War is another game that'd be really easy to write because the rules are stupid. So I remember as a kid playing it for hours, though I don't know why. So I wanted to show you that you can pass, even though this is the game and it's the abstract class, when I pass it in as Blackjack or BJ. So Blackjack equals new Blackjack. I pass that in. So player 1, I set the name and I set the hand. This is how many cards to give. So when I set the hand, so Blackjack usually get 2 cards first, right? So that's what I did is 2. There's a thing where I can show the hand, and then getting the hand. I'm not sure what the show hand and get hand were the difference, but then I loop through to actually show the hand and the results. Do the same thing for a second player. And if I run that, as I said, that's a lot of coding to do something really minor, which is to get 2 cards and 2 players. All I did was the deal. So 9 of clubs, 3 of diamonds, 5 of hearts, 9 of hearts. Those are the 2 hands. And it wouldn't be too hard to write the logic after that to just say what their total points are. And then the player could decide whether to draw again or just, you can't discard it in Blackjack. You can fold, right? And if you're a dealer, so you could write the dealer logic pretty, because there's certain fast rules about when a dealer has to hold and when a dealer draws. If I were to put in 3 cards here, it should just, 3 would not be a blackjack, but it should deal 3 cards. So player 2 has 3 cards and player 1 has 3 cards. So, as I said, that's an awful lot of code to do something so petty. But the idea is just to show the relationships and kind of map into the diagram. And again, if I think that the blog does that better. It's over here as it goes through, because it has the class diagram right above the code for each of them. Does that help at all? It was fun writing this, actually. I may fill it out and do the game. It's kind of simple, but it's I think it has most of the relationships and kind of the process. Anyway, if it helps, I hope it helps. I'm going to give you the next hour or so to work on your class diagrams, and then we'll see where you are on Thursday. So if you guys have mostly done this, then we'll start talking about the next thing. If you still seem to be mostly working on it, I'll give you more time. So whichever way it looks on Thursday. You guys are so quiet today.
It's a lot.
Yeah,
It's a sunny day.
sure.
Yeah, I know.
I gotta see what our next assignment is.
What we doing?
Was.
Are we leasing?
So.
Let's see what the assignment is.
And then the section is, like, how it has just basically an association. What? That section is basically. So of course it's like, this is.
Is it the group coding?
This
Oh,
room,
it's like 16.
this room, this.
What's the next one?
This is.
So we don't have one?
Because we did our classes.
Yeah.
Yeah.
She's just giving us extra time.
But it's, yeah.
Yeah, we already turned ours in. And I think it's
So I
pretty
think
great.
that.
Yeah, there were grades there.
Yeah, we had.
Right, so
Oh, yeah.
that doesn't make sense.
The relationship. Okay, so the next one is.
These are users logging, it's just. And these still all, I mean, they have username and password, but these are more than. Generally, we want,
Oh, so we get to try.
so you could do it one.
Maybe we should start.
I need to stop the video.
I think we're gonna
Yeah.
start doing.
Should we write this as a project?
Is there something?
Which, the thing for this, for the coding, no, you don't have to do. I would just, when I'm thinking about coding, which is something will be the next thing, you guys, pretty sure you got clear that and everything.
Yeah.
Alright, so I'm just thinking of taking a couple of classes and just writing the code for those classes, and not necessarily making like functional.
Oh, and they use conversation, right?
Unless he's gonna.
Well, so-
lecture more about this.
Run in the sense of maybe just initialize the class and assign properties to it, if that makes sense. It doesn't have to be a functional thing,
Okay.
unless you really want it. I mean, if you feel confident enough in your programming to do that, that's fine. But I didn't want to force anyone to do anything.
No, it's understand.
But yeah, I'll talk about, that's the next thing I'll talk about, so you guys are really ahead of the curve.
All right, video. I need to stop the video.